Hello, today I'm going to create a program that solves the binary puzzle module from the game Keep Talking and Nobody Explodes. Luckily we don't have to deal with any edge work to solve this module. So let's get into it.
Okie dokie.
We see a 6x6 grid that has a bunch of tiles. We can click on a tile and it will cycle through a 1, 0, and blank space. Looking at the manual, we see it's bare compared to the others. That's because the is a diffuser module, meaning the diffuser can solve this module with little to no help from the expert. I know that sounds like it's unnecessary to make a program that solves this module, but trust me, we need it. Anyway, the manual says we need to follow 3 rules to solve the puzzle. 1. No more than 2 equal numbers are next to or below each other. That means we cannot have 3 consecutive numbers in a row or column. 2. Each row and each column contains an equal number of zeros and ones. Since we're using a 6x6 grid, we have to have 3 ones and 3 zeros in each column or row. 3. Each row is unique and each column is unique. That one is pretty self-explanatory. Let's go back to one of our puzzles. I'll explain how I know what goes where later. In the meantime, try and guess what methods I'm using. There aren't any other methods that could help us solve this puzzle, we would have to guess and check to continue on, but for the sake of time, I'm going to cheat. This is why I wanted to create this program. A module should never force you to guess in order to solve it. Now that we know how the module works, we can start programming. The GUI is fairly simple. I decided to make it as close to the actual module as possible. There are 36 buttons in a 6x6 grid that all start with a white background. When clicked once, the button will become red. When clicked again, the button will become green. Then it will go back to white. Red represents 0, green is 1, and white is blank. Once the user presses submit, the program creates a 6x6 2D array of characters and fills it in with what the user gave. It's up to the program to use logic to fill in as many spaces as possible. The first move the program is looking out for is blocking two of the same tiles in a row or column. In this case we have two zeros in a row. We can fill these tiles with ones to fulfill the first rule. We can also use this rule to block the middle, as shown here. The second move the program will make is filling a row/column. Here we see 3 zeros in a row. Since each row can only have 3 of each number, the rest of the tiles are ones. The third move is checking the first and last tiles in a row/column. Here the first and sixth tile in the row are zeros. If either the second or fifth tile was also a zero, then the program would not be solvable. Since there can only be 3 of the same number in a row, the rest of the tiles have to be 1. But if that's the case, the puzzle is invalid since there are 3 of the same number in row. Therefore, the second and fifth tile has to be ones. We can do a similar thing here. The first and fifth tiles are zeros. If the sixth tile is also a zero, then we would have to fill the rest of the blanks with ones, invalidating the puzzle. We can also do the same thing if the second and sixth tiles are the same number. That means the first tile is the opposite number. We can use this rule one more time if the first or last two tiles are the same in a row/column. In this case, if we filled the sixth with a zero, then the rest of the tiles would have to be ones, invalidating the puzzle, so the sixth tile would have to be 1. The last logical thing we can do to solve this puzzle is to compare other rows and columns to each other. Since each row and column has to be unique, we can fill in incomplete rows/columns by comparing them to complete ones. In this case we have the second row already completed. The first row has 2 zeros. If we put a 0 on the same place as it is Indiana the second row, then we would have 3 zeros, so the rest of the spaces would have to be ones. But now the rows are the same, so that space has to be a 1. Although there are a lot of methods to figure out which space is what, most of the time, it's not enough to solve the entire puzzle. So there's only one thing left to do, guess and check. But having the program randomly guess all of the empty spots will be tedious and time-consuming. Since we don't know how many times we have to guess, we have to use one of my most hated topics of programming, recursion. For those who don't know what that is, recursion is a method that calls upon itself to complete the task. Since I used recursion in the maze video, I'll give you a brief summary of how that was used in that program. The program checks if it can go up. If that's the case, continue to go up until the goal is met, or it can't go up anymore. Then it does the same thing for going right, then down, and finally left. If the program gets stuck, it marks its current position as a wall, so it knows to never return here again, and backtracks to the previous position it was at before. Sooner or later, it will find its way to the goal. Go check out my maze video if you want to learn more about how I solved that module. So in the case for the binary puzzle, the program will find the first empty tile going left to right, top to bottom, and mark that place as a 0. It then sees if any logic can be used to fill in more spaces. Once no more logic can be used, the program checks to see if the puzzle is still valid going off on our 3 rules. If it isn't, then get rid of all of the logic-placed tiles, replace the guessed 0 with a 1, and do the same thing as before. If the puzzle is still valid, but not complete, then find the next space and do the same thing from there. This may sound not as bad just from me telling you, but I have spent the past 3 years of my life trying to find out how to get this right. I hate recursion so much. Anyways, once a valid puzzle is found, the program will convert the numbers into colored buttons and present it to the user. I'll show some examples of this in action.
So long, Bowser.
Thank you for watching the video.